Hello and welcome back to the continuation of our lesson on scientific computing with C. In this video, we would be looking at arrays, how to declare them, how to print them, and then how to populate them in C. So without wasting much time, let's get started. Now, the concept of arrays, right, is very simple but can be very confusing at times. So let's see. So practically or basically an array is just a stack of elements, right? So for variables, we declare an integer variable and then we call it maybe number and we assign it a value of 1, and then we declare another one, number 2, right? And then we assign a variable of maybe 2 and num3 equals 3, and so on and so forth. But then the question is, so what if we want to record or store the marks of maybe 100 students or 500 students? Does that mean we would have to declare 100 variables for numbers to store those marks? No. So this is where the arrays or the concept of arrays come into play or comes in handy. Also, if we want to represent matrices, right, how do we demonstrate them? Do we have to declare them one after the other? This is where the concept of arrays come into play. So let's see how we will do with them. So the concept of array is just simple, right? This takes the elements. So this time around, instead of declaring the variables one after the other, you can just declare one variable and then specify so the value it will take. So let's say you want to declare an array variable that takes in integers, right? You give it a name. So let's say array name 1, right? So array 1, and then you would now tell C the number of elements you would be storing in the array, right? So by including the number of elements, so let's say for now we have 5 elements, right? So C will now go into memory, create a space that can contain 5 elements, but then these 5 elements are all contained in one whole, right, in one chunk of memory. So and that space is what is called the array, right? Now every element in the array has an index. So and this index starts from 0. So even though they all belong to the array 1 variable, every element has its position or its place in that array 1 variable. So we starting from 0, we have, let's say if we have the number 10, 20, 35, 41, and then 61 here. The 61 would have an index of what? 0. So we have array 1. So for AR1, index 0 would have its element to be what? 10. And then AR1 index 2 will have its element to be what? 35. And then AR1 for index 4 would have its element to be what? 61. So basically that's the concept of array. So arrays can store several values and assign them to just one variable. So this helps us to easily get hold or control our variables or our values that we are storing into variables. Should you decide to change any value in the array, all you have to do is just recall that array and then point to the element, right? So the element you want to change, should we want to change the value of 41 to, let's say, to 51, then we point to the position 3, that's the index 3, and then what? Give it a new name of elements. So that will be a new value becomes 51. So once you assign it, it changes here, or you see the effect here to 51. So basically that's how the concept of array works. So this is a one-dimensional array, right? We could have two-dimensional array, so let's call this array 2. But then unlike the one-dimensional array, you would have to give it 2 elements. You tell it that, oh, so here you want probably 3 elements in the row, and then you want 3 elements as a row and then 3 elements as a column. So here it was going to create a stack, right, with 3 rows and then 3 columns. So column 1, column 2. So now this is going to be row 1, row 2, row 3. All this becomes column. So but then note that it starts from 0, so this will be 0, 1, 2. So this becomes what, 0, 1, 2, and then 0, 1, 2. So this will be row 0, row 1, row 2, and then column 0, column 1, column 2. So basically this is the concept of array, and then if you want to populate it, then you would have to be specific. So I want element in the array 2, index 1, that's for the row, and then column 2. So the index 1, column 2 would be here. So this element is the element you are looking for. Should you call this? And then basically that's how the concept of array works, and this is why it is important. But then note that the array, since it deals with indices, right, you would have to assign it the index of the element in order to get or populate it. Then we would have to iterate, right? We would have to iterate through the array that we have in order to get or put any element inside. Okay, so now let's go to our terminal and then see how we can demonstrate or create arrays in C. So we call this vim arrays.c, and then so here we include our standard input output, include the standard input output header library, and then our int main function, this will return void, so let's not bother. And then now here we would have to declare our array. So declaring arrays, right, declaring arrays, what we do is simple. All you have to do is ask yourself, what values would you be storing in the arrays? So if you want to store integers, then you call this an integer, and array 1, so ar1, array 1, and how many values would it take? How many elements would it receive? So here let's give it 3 elements. Okay, so now we are done declaring an array. If you want to assign the value, one way of doing it is assigning it directly, right, and then using curly braces and just populate the numbers, separate them by commas. So this gives us array 1, right? Now this is one way of doing it. If you want another array, let's say a floating point array, and we'll call this array 2, right, and then this also takes in, let's say, 4 elements, right? Now you can do this, right, assign this, and then this would know that yes, you have this array waiting for you. But then if you want to populate this later, you would have to look through it and then give the value to it. So if you want to get probably a value from the user to populate this array, all you have to do is just to use a for loop, right? But before then, let's see how we can. Okay, so let's populate this. So we use a for loop, and then we say for. Then as for for loops, we have to declare our initializer, so that's int I equals 0. Bear in mind that we said arrays are 0 indexed, so the index starts from 0, so that's why we are starting I from 0. And then while I is less than what, there are 4 elements here, so I is less than 4. Since it's from index 0, it should go from 0 to 3, so I should be less than 4. And then here we do increment I, so we increase that to ensure that the loop continues. Then from here we can now decide to scan, right? So first let's print that enter element, so enter element what, let's call it AI, right? Since we will be returning an integer, this will be %d, and then we want it to show that enter element 1, so that we can relate as humans. So here we can just do I plus 1, right, so that it will add 1 to whatever value I is, so that we can see. And then now we get the input from the user, so we use our scanf function, and then from the scanf we take the element. Since this is a float, we would have to give it a float, so %f, right, and then we give it the address of the elements, right? Now as I said, since this is since this is we will have to get the address of each element. We'll have to give the address of, and then call the name of the array, that will be array 2, but then show the index, right? So index to the ith element, right? So it means that once you say enter element whatever, then it will take this input from you and then put it at the ith index, right? Else it will just keep replacing it at the same spot, but we don't want that. Interesting. So let's save this and see what our output will give us. So we save this and let's compile our code. So gcc, then we call this array.c, and then we want the output in array.x, right? .x. So once you compile this, you don't have any error. Let's run this and see array.x. So here it's saying we should enter element 1. So if I want 3 to be my element, I enter element 2, 4, 6, 5, and then that's all. So yes, it has asked us for the elements we are to enter, and then here we are. So but then wouldn't it be nice if you can print this out to the screen? Very good. So here we can decide to, so this is for taking input, right? So let's say taking input from taking array inputs from user, right? So this is that. Now printing the what? Array inputs, so content of array. So here printing the content of the array to screen. So here to, since we loop through the elements to put them there, we would have to also loop through them to get them there. So int I, bear in mind that since we are declaring this integer here, it's not global, so we can't use it outside here, so we would have to declare it again. So I equals 0, right? And then I less than 4, okay, and then increment I, so that, and from here we can now print f. So now we have just printing, so we can print f, our what, element. So we can say that we can just print the element straight forward, percent f, since the array was a float, so here, and then now here we do what, we show the index. So if you do array like this, it wouldn't work, it will return an error, so you'd have to show it points to the index, right? So we want the ith element from the matrix. Now when we do this, we'll see what we'll get, but then let's give some space here so we can see our output nicely. Now we have that. Okay, so let's save this and see. We will recompile this. So GCC arrays dot c output to array dot x, right? We compile it to x. Now let's run our code. So elements 1, 2.5, 5.7, 8.9, and then 6.7. 5.7. Okay, let's do this. 4.3. So yes, we see that our elements are that. So it has printed the elements to screen for us. So here you can still do all the formatting you want. If you want 2 decimal places, you can just do 0.2 f here. If you want it to move to the next line, if you want it to be printed as a column matrix, all you have to do is just put a \n here, and then it prints it nicely as a column for you. Let's rerun this and see what happens. So let's see. So now let's rerun this. We'll have 2.4, 6.8, 7.9, 3. So you see that now it has been printed as a column matrix for us, or a column vector for us. So whichever way you want it, you can always print it that way, right? You can always print it that way and it will look nice. So basically we have this, and so this is for one-dimensional arrays, right? So for one-dimensional arrays, so this is 1D. So let me clarify that. One-dimensional arrays. So now let's go to the two-dimensional arrays aren't different from that, just that you would have to do things double. So here, declaring two-dimensional arrays. So let's do it 2D, so that arrays. Now, so here we could also decide to call this matrix, right? So mostly we like to call them matrices. So if you want to define a matrix, let's say a 2x2 matrix, so you can just do mat A, right? And then this, since it's 2x2, 2 rows, 2 columns, right? And then you close that. As I said, you can choose to populate it from right after declaring it, right? So this time round we use 2 curly braces in a curly brace. So here it's nested curly braces. So this first one is representing the, so each curly brace is representing the row. So this is row 1, this is row 2, right? So if you want the number of elements, the columns, then let's say you put the first element in the first column, that will be 2, 5, and then the next one, that will be 3, 6. So should you print this out to screen, you will see that you would have to, they will be printed, you would have to make sure that they are printed in the row and column form for you. So in order to get the elements from this, right, or you can choose to also math B, right, and then so let's say 3 by 3, right, and then you choose to receive input from the user to populate it yourself. You can also choose to do that, but then bear in mind that if you are doing that, you would have to loop through the matrix to do that, right? So let's see. So how to print elements from the matrix, right? So printing elements of our matrix. Okay, so here we would have to print the elements. We still use a for loop, but this would be a nested for loop, right? So for element, so an integer I, this is our initializer, and it's equal to 0 because the index is starting from 0. So while I is less than the first element, the first matrix is what? It's a 2 by 2, so we can just say less than 2. That is if we are printing the elements of the first matrix. Then we increment I, so that will be I plus plus. Sorry, this is not I. Okay, so I plus plus. Then inside this loop we give another loop, so for loop, so that the first outer loop, right, is for the loop. This loop is for the rows, right? So this will loop through the rows, and then the next one coming here would be for the columns. So let's see. So for what? Int, so this time around let's use a different integer, int j, so it doesn't confuse us. For int j equals 0, right, and then j is less than 2 because we have 2 columns here as well. J is less than 2, and then we increment j, so j plus plus. Now we can now perform the task, right? So we want that when it gets to the I0 portion, right, what should it do? It should print I0, right, and then also do what? Get us or give us the element 0 from 0 to 2 to 1 for the columns. Get to the second row, get us 2 elements. So let's print what? Print f, but then this time what are we printing? We are choosing to print the element, which is %d, right? Here it's %d for that element. Now here we supply it what? Mat a, right? But then we'll have to give it a column index and the row index of the elements we want, right? So here we want the first, so that will be the elements from the ith row and the jth column, right? So it will print the elements from the 0th row and the jth, that will be 0 column, and then from there it then continues to print the elements in the 0th row, the 1st column, and then now when it's done it moves back, changes I to 1, and then does this multiple times again, and then stops when it's done, so gets out of the loop when it's done. So this is what happens. Let's save it and see what we would get. Now we want it to print it nicely like a matrix, so here we would have to come out of the inner for loop and then decide to print a new line here. So let's print f, a new line, right? So now if if you print a new line, since after the inner loop it prints a new line, then sets I to 1, does the same thing over and over again. So let's see what happens here. So let's clear our screen, right, and then recompile it and call there. So let's just, this is the first code. Okay, so now you could see that the element is 2, 5, 3, 6, but then they are written in the form where you will not see the difference. You think it's 25 and 36. So let's space it out. Let's give it some space. Let's say 2 spaces. I think that will be fine. 2 spaces will be okay. So 2 spaces. So let's give it 2 spaces. And then now let's save it and rerun the code and see what happens. So this is different. Now we see that it has given us 2, 5, 3, 6. So this is the matrix, and it has been printed nicely for us here as we wanted it, right? So, and then we populated that using the 2, 5, 3, 6, right? So the similar thing goes for scanning or getting the elements from the arrays, right? You can choose to just repeat the same thing, but then since it's a 3 by 3 matrix, you would have to change the I to 3 and then the J to 3 as well, and then from there you choose to do what? Change this printf to scanf, and then give the address of I and J respectively to get your matrix element. So basically that's how we do with matrices. We declare them, print elements from them, and also assign elements to them. So in the next video we will be looking at another activity that deals with the matrices and see how we can perform matrix multiplication and transpose some particular matrices. Thank you.